Anybody watching the NCAA tournament? Anybody know how many brackets are left in the running for $1 billion? It was done like the second, I think of this, second round, it was gone. It was like 16 people left out of, I don't know how many people, 11? Yeah, 16, I think 16 were left. It's a beautiful showcase of probability. Now, you know I got to go there, right? I mean, they're like, sure, $1 billion. I'll give you $1 billion if you do it, because they knew it was essentially impossible. Right. If you really, in fact, I'm thinking about making a problem about figuring out probabilities associated with that, so you can just see how tiny they get. But let's, of course, San Diego State. You never know. They got a number 1 seed knockout. It would be the second number 1 seed out. I think Wichita State's out now, right? Yeah. Of course, the rest of you are like, I really don't care about basketball. Please stop talking about it.
For people who actually do know basketball on the test.
Yeah. All right, so let's see. This test is going to cover section 3-4, right? The box plot kind of stuff, the percentiles. Chapter 5 and chapter 6, except for section 6-7. You only have to have up through 6-6 done. Homework. We haven't talked about 6-7 yet. It'd be kind of evil for me to say do it. Chapter 7 and 6-7, that'll be on the next test. Okay. So, section 3-4. I love this idea. Section 3-4 was the box plot stuff. There's really nothing you want to write there, I don't think. There is a formula. But that's more confusing than anything. I mean, if I want the 57th percentile for a list that has 120 numbers, what would you do?
120 times 0.5.
Yeah, take 57% of 120. If it's a whole number, you average that with the next one. If it's not a whole number, you round up and you take that one, right? That's the process. I wouldn't even write any formulas down unless you use them and understand them. Right? To me, they just get in the way sometimes with probability. Section 3-4 actually is also where they introduce z-score, but you don't really use it till chapter 6. So to me, it's kind of silly they introduce it so early and then we forget about it for a while. There won't be any probability stuff on here specifically. It won't be anything from chapter 4. So we have chapter 5 is where we have this stuff here. Right? So however you want to put this up, put standard deviation like this. So that's when I give it to you, of course, in the table, xp of x. It's kind of a giveaway. If I give you something with xp and x in it, you probably want to use the formulas that have xp and x in it. So the next one we learned was binomial stuff. All right, so we have the binomial probability. It always looks a little worse in formula form than it really is. Hopefully most of you guys agree with me. It's one of the nicest formulas ever, actually, in a way. And then we have its mean and standard deviation. Now don't forget, let me say this again. I don't know if you've noticed, but my handwriting is bad. Just to let you know. So I would, if I were you, I would not write what you're seeing on the board and then immediately take that to the test and use it. I would probably look it up in the chapter and make sure that I didn't read that as an R, P, or something. You know, like, what the hell's R when you get to the test? No, probably look these up, right? So that's the first part of chapter 5, the second part of chapter 5, and then we get chapter 6. Right? Chapter 6 is where we have the z-score comes back. You have the other way around. What are you up to, man? We have, let's see, what else can we do? Pretty much those are the only two formulas you have to use for like section 6.3. The rest of it's on the chart that I'm going to give you. And then 6.4, 6.5 is where we start doing this thing. And I don't know if anybody of you realized, the z-score formula changes a little bit, but to be honest, the z-score formula actually never, ever changes. Ever. Officially, I'm not even going to, if I were you, I wouldn't even write this down. Officially, the z-score formula is now all that crap. But it's still the data point you're interested in, minus the mean of those, divided by the standard deviation that's right for the situation. It never really changes from this. Believe me or not. Right? But if you want to, you certainly can write that down, if that does make sense to you. Okay. Cool. Am I leaving anything out? Does anybody have anything they want to suggest we add? No? Normally I have at least one smart ass say, they're going to put examples and problems. No. Right? No smart asses. Come on. All right. So seriously though, anything that you think I've left out? I don't know if I really want to trust my memory entirely.
I just have a question. So it's like for 3.8, we have to figure out for 3.8.
3.4.
3.5.
And then so section 3.4, chapter 5, and chapter 6 up to 6.6. So the test is section 3.4, chapter 5, and then 6.2 through 6.6.
Except you have to.
So that's the homework.
That's the homework you have to turn in Wednesday.
What about section 4?
Chapter 4, yeah, chapter 4's homework is due this Wednesday, but it's not going to be on the test. Right, we had its own little mini quiz already, or mini test or double quiz. It's going to be on the final, but it's not going to be on this next test. That would be way too much stuff, yeah.
And the practice is due on Wednesday, right?
Yes, good.
Both of them?
Oh yeah, both of them. Okay, yes. Yeah, but that's more of an idea. To get the minimum and maximum expected value, how far do you go? 2 standard deviations up and down. So notice it's not up on here. So it better not be on your formula sheet. That's more of an idea that you have to know to apply. Yeah.
Do we have to know what is considered unusual?
Yeah, those two go together. Right? So unusual would be anything further than 2 standard deviations away. Because we just defined what would be the usual min and the min and maximum usual value.
On the homework it says on one of the sections it said to like find which one is like unusual. Like what percentage would be considered unusual?
So a long time ago we figured out that less than 5% would be considered unusual, and that's really goes along with 2 standard deviations out. For a normal curve, how much of the data is inside? 95. So how much is outside?
5%.
5%. So if this is unusual, that means anything out in this area where there is 5% of the information would be also unusual. Okay, cool. So anything else there? Okay. Cool. If you have anything else you think you want to put on your formula sheet, run it by me first. If you have anything else on your formula sheet, I will probably take stuff off. If you want to just add this to your first formula sheet, if you didn't lose any points on it, that's great. You can just start bringing, I don't care, you can bring all your formula sheets with you to every test. I don't care. How many, index card? No. Right? Did I already make my grain of rice joke? Someday they're going to make you write on a grain of rice, right? And we'll just be laughing. Ha! I never really understood that. You can have reams of freaking paper as long as it doesn't bother anybody, and as long as it only has formulas. So if you want to put one letter, Z equals, that's fine. Right? As long as you don't bother anybody, don't let it fall over and kill somebody. I don't care, right? Okay. All right. Oh shoot! Hopefully you guys got that. So now I'll open it up wide open if you have a question from the quiz, question from the practice test, question from the homework. Yeah.
I have a question about 6.4, number 9.
So 6.4. So this is page 274. And the nice thing about the homework in section 6.4, some of you guys might consider it to be the only nice thing, is table 6.4 on page 271. You guys with me? So in this problem, every single problem I assigned you in the homework deals with having the numbers 2, 3, and 10 in a hat. So like number 9 says, blah, 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 blah. It says that. And then it says, find the median of each of the samples. So if I put the numbers 2, 3, and 10 in a hat, this table already lists all the possible samples. With me? So of course 3 of them would start with the number 2. 3 of them would start with the number 3. 3 of them would start with the number 10, and that's why there's 9 total. 3, 6, 9. Is that cool? So they've already got the table set up for you. And in that table, they did the range. They got the ranges, and they got the probabilities, and blah, blah, blah. You want to do, for number 9, you want to do the medians. What would the median of 2, 2? What's the median of 2, 2? 2. It's crazy. And the really funny thing is, if I have 2 numbers, really think about this. If I have 2 numbers, the median and the mean will what?
Be the same.
Be the same. For 2 numbers, the mean is the number that's right in the middle. And the median is the number that's right in the middle. So number 9 says do the medians. And let's see, number 12 says do the means. Same damn thing, right? Number 9 and 12. Once you do number 9, you basically now got number 12 done. You guys with me? I just want to point that out about this homework. Because this homework, when you start to do it, seems a little daunting. They're like, oh crap, what the hell's going on? But this is basically what you do. You make a list of all the medians. Then you're going to take an average of the medians and compare it to the real median. What's the real median for the population? What's the real median here?
7
Oh, come on. What's the median for 2, 3, 10? 3. The number is right in the middle. So you're going to find the average of the medians and compare it to the true median and see if they're the same or not. The only difference in number 12 is you're going to take the average of the means, which are all the same numbers, and compare it to the actual mean and see if they're the same. That one, they will be the same. That's exactly what we talked about. They have to be the same. The medians, I don't have a good feeling for them. I don't think they're going to make it. So number 10 would say use standard deviation. So number 10, you have to figure out the standard deviations for each of these samples. Now, 2, 2, what's the standard deviation for 2, 2? 0. I love it. How far away do they get away from their own average? 0. They never get away from it. So to do the rest of these, if I wanted to do 2, 3, I would put it into list 1. Hit stat, calc, 1 var stat, and then just read it off. Make sure you take the sample standard deviation, right? Now that we're outside of chapter 3, if I don't say so, you can't, you can totally take that from the calculator, no problem, right? I only make you do that for chapter 3. I only make you do the tables. You never have to do that again. So you can just put in a list 1, 2, 3, and guess what? Once you do 2, 3, you got 3, 2, right? And 3, 3 is going to be standard deviation of 0. I mean, so it's a lot quicker than it first seems, possibly. Yes, sir?
How'd you get the standard deviation of 0?
Standard deviation is how far away on average every data point gets away from its mean, right? From the mean. So the average of 3, 3 would be
0.
The average of 3, 3 would be 3. How far away do these get? 0 away. Yeah. So it makes sense. Standard deviation for a data set that doesn't go anywhere, it has 0 spread. So it makes sense it should be 0 standard deviation. Good. Okay, maybe. 6.4 is the freaky conceptual section. That's why I only assigned a few problems. 6.5 is the nuts and bolts. The easier one, the one where we apply this, right? And that's the only difference. I divide by that standard deviation instead of the old one in the z-score formula. That's a beautiful, let that be nice. And it so matches up with what we expect. If I take a sample, their average should be closer to the real average. So all the samples should get closer. So standard deviation should get smaller. It should be less likely for something to be very far away. Right? You got it?
Yeah.
Get it down. No, sorry. Everybody here thinks I kicked it from me, I think. Get your pen. Yeah.
6, number 13.
Good, cool. And actually, whoever asked about this, I just kind of went off. Did I actually address the question you had?
Well, it said to put a table down.
Good, so this is the table. You just copy the one from 6.4.
Oh, okay.
But instead of, they have ranges here, just put medians there.
Oh, okay.
So you can use that same table for every single problem because they all relate to the 2, 3, 10 population.
Okay.
Yeah. So number... Which one did you say? 15? 13. This is page 294. This says, blah, 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 blah. How do you say that? Find the indicated binomial probability by using table A1. So we kind of looked at the table a little bit. Table A1, it's back in the back. Why do they say this? So part A is use table A1. In Appendix A, good. Part B says if NP and NQ, and actually this book has equal to. It depends on which book you use. Why do they say, why is that important? Why is this step here important? What would this tell me? If NP and NQ are both at least 5, what would that tell me? It's normal enough. I like it. If you just say normal, I'm cool with it. But this would mean that it's normal enough. Normal enough to do what? Good. To use z-scores to look up probability. So I want to be really clear right now. You can always find a z-score for any data set. I don't care if it's normal. I don't care if it's weird as all hell. You can do a z-score. But that z-score will only directly relate to probabilities that we know of if it's normal. Then I can use the chart, right? So I can only use z-scores to get probabilities if it's normally distributed. This would tell me it's normally enough to do that. So for this problem 13, it says n is 10, p is 0.5. Find probability of 3. So if n is 10, p is 5, what's NP?
5.
Yeah, half of 10. NP is 5 and Q is 5. So they're both
Equally.
exactly 5. So the further above 5 you are, the better chance you have of being a good approximation. This is right on top of 5, so it might be a rough approximation, but
Does that mean it's equally likely if it's 0.5?
that means it's perfectly symmetric. But it might not be. It's not enough, not really. It's just barely a big enough sample with this probability to match this. Yeah. Okay. So part B says. Let's try this one. This is a little bit of a small sample. So when I say this phrase, what does that mean? You're like, man, a lot happened this weekend. What do you want from me? Yeah.
Normal approximation.
It's up and down by 0.5.
Good. You know you're going to have to use a continuity correction. And like I think June, you started saying, this stands for normal approximation to the binomial distribution. I just sorted it to NAB. Thank God. Right. So when I say use the NAB, when I say that, like I do on number 6, part 2C, on the practice test, and I even put it in bold, that tells you you're going to have to do that continuity correction. Because I'm using like numbers of people and I'm pretending like they're continuous, as if you could have 339.78 people. Really freaky for the last 0.78 person, right? So this problem is a little bit weird because the sample is really small, but it just barely clocks in as normal enough. What do we already have up here that would help me for z-scores? What two things do I need to calculate a z-score? What is the formula for a z-score?
X minus X. Mu minus standard deviation.
Good, so I need the mean and the standard deviation. Cool. I already have my x score right there. 3. All right, so this is going to get a little freaky. Let's see if we can handle it. But if you remember that handout that we looked at twice, the one with the histogram in the middle, flipping a coin, flipping 14 coins. You guys remember that? We looked at it a couple times. When I said 6 wasn't really 6. 6 is really 5.5 up to 6.5. So when they say probability of 3, they don't mean 3 really. They mean 2.5 to 3.5. You're going to have to find that area of that block. All right, so when I draw this, so let's first do this. What do I already have here that I need? I need those two things. What do we already have? What did we already calculate? What's the formula for the mean?
NP?
And did we already do NP?
Yeah.
Hell yeah. Right? NP is 5. So the mean is 5. Help me on the standard deviation. NP is 5. Q is 0.5. Right?
Your root of it is 5.
Q is 0.5.
Never
P is 0.5. Q is 0.5. So the square root of 2.5 is something. That much I know.
1.58.
1.581?
Yeah.
All right, so I'm hoping we spent enough time, and I think we did, on like the handout for the z-score stuff. Have an x-score, you make it into a z-score, you look it up in the table. Everybody should feel decently comfortable with that process. So if I'm asked to use the normal to get a z-score, I know I need those two things, because that's how I make a z-score. Take the x from the question minus the mean divided by the standard. That's how I make a z-score. So I know I have to first calculate those two things. And me being me, just like on 6.2a, I ask you to find the mean. I ask you to do it first. You've already done it. So then later you can just use it. So the question is, what's probably a 3? What would this look like? I know it's approximately normal, or normal enough. So I'm going to draw the normal curve. What goes right in the middle? The mean, which is? The mean, which is? 5. Right? I haven't made z-scores yet, so the mean's not 0 yet.
So the mean and the median goes in the middle?
Yep. For a normal curve, the mean and the median will be the same thing. This is just normal enough, though, so we got to be careful. I'm here about 3. Now, if I'm using the nab, if I am using the nab, I know I can almost sense somebody out there going, what the hell is she saying? But if I'm using the nab, what should I put up around the 3 to help me out? A little box, because that's what the hell it really is, right? This problem is all about, well, they don't tell me. Let's pretend it's all about people. And you have 3 people, 4 people, 5 people. So what I really have is 3 is like this, then 4 has its own box, and then 5 has its own box. And I've just approximated it with the normal curve. So that's really what's going on. So this continuity correction that you talked about that back there is to correct for the fact that I don't have continuous data. How do I pretend like my data is continuous? I pretend like 3 is not really 3. I pretend like you told me 3 is really 2.5 up to
3.5.
3.5. And then 4 is
4.
3.5 up to
4.5.
So now, are there gaps between my values? No. They all run into each other. You guys kind of with me? That's, on one level, it's like, whoa, really? You just pretend like this stuff is continuous by doing... Yes, that is. It's silly how good the approximation is. It's kind of kick-ass cool. To be honest, it's like, very simple idea. It's not really 3. It's really 2.5 to 3.5. It sounds like a government thing. You know, let's make it 2.5, 3.5. But it works beautifully for probabilities. Okay. So now my question, now this is the weirdest question you could ask with this, and I don't know if you guys really understand. To get the probability of 3, what would I shade on my picture? Does it say greater than 3? Does it say less than 3?
No.
It says 3. But what is that on my picture? Yes, good, it's this block. And that's from 2.5 to 3.5. So how can I, the continuity correction for this would say 2.5 less than or equal to x, doesn't really matter, plus or equal to 3.5. Now that I'm used to. I know how to tackle that problem with z-scores. I totally do. How do I tackle that problem with z-scores?
Subtract each and every.
Yeah, make each one of those into a z-score, look up the areas, and then subtract. I love it. Right, we've done several of those, yeah.
So we have to draw an arrow what's greater than 3.5 and what's less.
Well, I just did that for a better visual, right?
So we subtract 2 numbers.
But whatever you do, I would put a block on there just to keep me straight, right? So now you just make that into a z-score. Make that into a z-score. What would that be as a z-score? It'd be 2.5 minus 5 divided by 1.581. I love it. Because that's the standard deviation, right? And then whatever the hell that is. We might find out. I don't know. So 1 point. Oh, that makes sense, because the square root of 2.5 is that, so 2.5 divided by that should be that same thing. I don't know if anybody followed me at all. It kind of makes sense. Doesn't make sense, it's all right. But I'm just going to round that, of course, to negative 1.58, because that's as far as my chart goes, right? So that's negative 1.58. Let me draw this again. So I got 5 in the middle. There's my 3. There's my block. So 2.5 would be negative 1.58. 3.5 is going to be (3.5 minus 5). Is that cool? Just change 3.5 into a z-score. That's going to be negative 0.95.
Yeah,
sound good? Okay, so that's negative 0.95. And now you just have to, if you look up negative 0.95 and look up negative 1.58, subtract them to get right in there. Right? Let's do that. Go ahead. Look up negative 0.95. What do you get? It's my 8th puberty right there. You know we're supposed to have one of those. I hear rustling. Let's see. So when I look up, what did I ask you to look up? Negative 0.95. Who's got that? 1711. I like it. And when you look up negative 158, what do you get?
0.0571.
0.0571. So of course, you get the area, and that's just right there. I subtract those two things, right? That makes physical sense, which is always nice in math when something makes physical sense. So 0.1711 minus 0.0571 is something 1140. Does that sound right?
0.114.
14, good. So this area here, so just over 11% chance to be in there. Now, let's look at this a different way. N was 10. P was 0.5. So it means Q is 0.5. What's the probability of exactly 3? How would I set that problem up using the binomial probability formula? Good, yeah. So I got 10 things, choose 3 of them. So I want 3 of those, and I want how many of those?
The rest.
The rest, 7. So help me out. What is that?
Except can you just do
I didn't bring any
easier,
calculators.
just do 0.5 to the 10th.
Exactly, I love it. If you see that, that's the one time you can combine these two as if they're the same base. You can always make 0.5 to the 10th for that kind of problem. I love it. The only thing that would change would be this first piece. Anybody have a
1117172.
second? 0.117?
7.
2? Okay. So those are off by 0.3%, roughly. Which for a guess, an estimate, is pretty damn good to be off by 0.3%. Are you guys kind of with me? Now I knew. Now this is still. I think some of you guys would agree with me. That's still kind of relatively far away in a way. But remember, what was NP and NQ? They were both exactly 5. So I knew going in, my approximation was right on the edge. Right? If either one of those was just a notch down, I couldn't even use it. Math would say it's probably going to be too bad. Don't use it. They were just barely good enough to use. Considering that, that's pretty damn good. Okay. Now, if I would have said, you guys want to see another NAB problem? I think that's pretty much where we left off last time. So that's relatively new for us. So let's make a new situation here for NAB. Second? Sure. What do we have there? So if we take 356 adults, and the probability that they think DNA testing is reliable, or very reliable, is 0.88. What would Q be?
0.12.
Yeah. And please do that, maybe just to be really safe. Do 1 minus 0.88 in the calculator. I get way too many people saying 0.22 there, and basically everything's wrong after that. So then I have to grade based on, did you do it right with the wrong numbers? So it becomes a grading dilemma for me, right? But just do the 1 minus 0.88. Just be careful. I mean, I'll do a stupid mistake like that too, so I'm going to do it in the calculator just to make sure. So now this is saying use the NAB to figure out the probability that at most 340. Now what the hell does that mean, at most 340? If I graph that, what's it going to look like? What's going to go right in the middle? Do I know yet?
356. No.
Don't know yet, so I got to figure out the mean and the standard deviation. All right, so the mean will be 356 times 0.88.
313.2.
Who is it? 313.28?
Yes.
And the standard deviation, 356 times 0.88 times 0.12. Try more. 6.13. 6.131? Yes?
Yeah.
Okay. Cool. Yes. How are we doing so far? Now that was question 6.2a. So I asked that by itself. You have to find the mean and standard deviation already. Part B says check NP and NQ. NP is that good? Does that check out? It has to be what? At least 5. So that's definitely at least 5. NQ, let's check that real quick. Check. NQ would be 356 times 0.12. 42.72.
Yeah.
I got to do 356 minus that because that's got to be the rest. And that's definitely bigger than or equal to 5. So both check, which tells me what? That check right there tells me what? Normal enough, thank God, because I already drew the normal curve.
Oh.
So thankfully the check works. If either one of those comes out less than 5, you can officially say, I cannot do this problem, Jeff. I'm going to the next one. Right? That just means either I didn't make it careful enough, or I did it to you on purpose, which I normally wouldn't do. Because you can imagine, I could design a problem where you shouldn't have to do any work, and if somebody misses that and does the work, they're screwed. They're losing time. That would be a little evil. I'm not going to do that. So if that happens, you've probably made a mistake. So what goes right in the middle?
313.2.
313.28. I like it. And I'm interested in the number 340. and I want it to be at most 340.
Less than 340.
Good. So it's got to be,
Anything.
and let's be careful now. It's a nab, right? So what do I want to put here? Box. Now, if I want to be at most 340, do I want to include 340?
No.
If I didn't want to include 340, I would say less than 340. So I have to say at most 340 in that weird situation when I want to include 340. You could be at most 12 to eat off the kids menu. So if you're 12, you're good. You're good to go. You're at most 12. 13, that's too bad. Yesterday's your birthday. I don't care. Too bad. So if I want to include 340 and I'm shading down, do I start at the front or the back end?
The front.
If I start here, do I include 340?
No.
No. So I want to start there. So I start at 340.5. There's no memorization unless you really want to. To me, it's just wasting brain space. I know I don't have much space left up there. You just draw the box and think for a second. Do I want to include it? If I start here, I don't. Oh, I better start there. So, because you're either going to make it 339.5 or 340.5. You just got to figure out, do I include it or not? So if I would have said less than 340, I would not want to include it. I would have started at the front end. 339.5 would be my correction. Right? Okay, maybe. So now this question becomes, through the continuity correction, becomes the probability x less than or equal to 340.5. Cool. And now you make your z-score, so forth. Everything's the same after that. So section 6.5, the standard deviation changes when I take a sample. That's the tweak. Here, the number itself changes when I have to use the nav. That's the one tweak. Once you make that tweak, everything after that's the same. So now I can make a z-score out of it. How would I make a z-score out of this? Z equals
X.
good, 340.5
minus the
313.28.
Divided by standard deviation.
Standard deviation 6.131. And I have two of these situations on the practice test, so it's pretty good, because I don't think we really hit that yet. What kind of z-score do you get here?
4.44.
4.44. 4 point doesn't really matter, because is that on your chart? No. Now, on the chart, if you don't have the chart, I'll tell you. On the chart, it says 3.5 and up has 0.9999 below it. So they say in the book, you might be able to catch from the way I'm saying this, that I disagree. They say if it's above 3.5, so 3.51 and up, it's always going to be that, which is not true. The minute I move a little bit more, at some point it's going to become 0.99999. Right? If I just keep moving up, I keep getting more and more stuff below me. I keep passing more and more stuff. So this is what I said. If it's off the chart, it's either 0% or 100%. Depends which way it's off the chart. You with me? Because the other side, they say it's 0.00001. Again, same faulty reasoning. So if it's off the chart, it's either about 0% or about 100%. So in this case, since I'm asking at most 340, and I'm way the hell up here at 4 point something or other standard deviations, how much is below me? Essentially, 100%. The whole damn thing, essentially 100%. If I would have said greater than 340,
0%.
Yeah, about 0%, because I got about the whole damn thing below me. So what's above me? About 0%. So here it's below, so it's about 100%. In human terms, it's freaking going to happen. In mathematical terms, it's 0.9999993 or something, right? Which to me is basically almost 100%. Okay, maybe. So I have another situation number. Which one was it? Oh, Which one are you? 5D has something very similar happen, where something's off the charts. Okay. So let me do this. Let me go ahead and give you guys the answer key. It's between, what's the smallest probably? No, the smallest probably to be in general. The 0. What's the biggest one? So you have to say that. It's 0 to 1. Because you could meet this by having 1 above 1 and 1 less than 0. So then maybe they still add it to be 1. You have to say both to be complete. They add it to 1 and they're all between 0 and 1. Yep, thanks.
Yeah, it's usually I think it's 2 years or depends. Yeah.
Shoot. Make sure you have a front and a back. See, on number 8, I forgot to do part A. That shouldn't be too horrible. What do you have to be careful about when I give you a list of data? What's the first thing you should do with it when I'm asking you about percentiles and quartiles? Put them in order, because otherwise it doesn't make any sense. I always have somebody just leave it the way it is, and they come up with weird numbers all over the place. No, they have to be in order to make sense. Yeah.
How do you do the points on the quick correction?
So, you mean just on the quiz correction, like if you got an 80 or above, you get 5 points back max, up to 100. If you do all the corrections, get them all right. So don't just do 5 points worth of corrections. That's where people get confused. If you do all the corrections, get them all right, I'll give you at most 5 points if you got an 80 or above. If you got below an 80, I'll give you a point for every 4 you missed. Every 4 points you missed, right? So if you got a 68, you missed 32 points. Divided by 4, you can get 8 points back. If you get them all right, do them all, get them all right. Cool. And on top of that, if you do that, and you do better on the test, your quiz grade will go up. If you get all the quiz corrections right, so if you got a 30 on the quiz, so you had a really bad day, you didn't do any homework, and you got a 30 on the quiz. You do all the corrections, get them all right. Right? So that gives you, well, it'd be 17 points. Right? So you get 17 points, so now you're up to, 47. Yes. But then you get like a 80 on the test, because you do all your homework, you study, you get an 80 on the test. Your quiz grade is now an 80. Oh is right. So I am being really nice, but I'm being really mean, because I'm spoiling the hell out of you. Have any more math classes to take? They're not always going to do that. My higher level courses, I actually make the grading, the points you get back becomes less and less. I'm a little nicer to my non-Calc 2 people, for example. They better be more right more often. Good. If you are ready for the test, you do not need to sit here and stare at me. Right? There you go. Or at least you. If you're not ready for the test, let me know how you are not ready. Ask questions. Yeah. Yeah, so at least 3. So if you give me 4, it's even better. No, something.
I can't do this.
What happened here? Yeah, this was right. Put that in the calculator again. You shouldn't get this number. Your formula was right, but then you got the wrong number. Yeah.
I had an off day. I had 3 quizzes that day, so
Okay.
I didn't study for yours.
Thanks for letting me know.
But it's on the back.
Yeah, I got you. Yeah. Thank you.
Do you have the original practice test?
Oh, yeah.
And my quiz?
Yeah, it's right here.
Yeah, that's just nice.
3.4.
Cool.
Oh, like on the bottom somewhere.
My notes at home. I got 3.
Ah, there you are. Good
Probably not,
stuff,
but I'm
man.
gonna be doing all that work
Just on this one,
the next 2 days.
they add up to 1 and they're all between 0. So say both of those together. So just put that down. So you always have to tell me they add up to 1 and they're all between 0 and 1. Because you could have a negative 1, and that's why they add
I
to
knew
1.
how I would do.
Alright, cool.
I missed the
The quiz? Let's see if I have a...
do it, I would get
Wait, I see it. You have nothing to complain about.
If I have a copy, you can have one just to see what it look like.
How about because you have like
There we go.
59.
So you can't do this for any points, but what's going to happen is your test grade takes the place of this
Thought I did.
quiz grade. You can have that just to see what it looks like at the end.
So why do you think I have?
So what do I do?
I shouldn't complain about?
Oh yeah, just don't do it in the future.